You know, when we look up at the night sky, our minds immediately go to planets, right? But what if I told you that orbiting those huge planets are worlds that are just as complex and, honestly, in some cases even more dynamic than the planets themselves? That's what we're doing today. We're going to take a tour of the giant moons of our solar system, places of incredible fire, ice, and just mind-blowing possibility.
Okay, so we're all familiar with our moon, right? It's easy to just assume that all the other moons out there are kind of the same. You know, gray, covered in craters, and, well, pretty lifeless. But the reality? It is so much more incredible. The sheer variety of moons in our solar system is it's truly astounding.
And I mean, just look at the numbers here. Jupiter and Saturn alone have over 123 known moons between them, and we're constantly finding more. That is a staggering number of worlds to explore, and every single one has its own unique story.
So, these moons, they basically fall into two main camps. You've got your irregular moons, which are probably captured asteroids with these wild, eccentric orbits. And then you've got the ones we're diving into today, the giant moons. These are massive, spherical worlds that actually formed right alongside their parent planets. And trust me, they are absolutely spectacular.
All right, so what actually makes a giant moon giant? Well, it really all boils down to its shape. And the reason these big guys are all nice and round? It's because of one of the most fundamental forces in the universe, gravity. It always wins.
Okay, the key idea we need to get is something called compressional strength. Just imagine this. You take a rock, you stick it in a hydraulic press, and you see how much pressure it takes to crush it. That's its compressional strength. Every object out there in space has this property, and it's what helps it fight back against gravity trying to pull it into a sphere.
Here's how it works. A smaller moon, a little lumpy one, has enough internal strength to keep its weird potato shape. But as it gets more and more massive, gravity's inward pull gets stronger and stronger. And then eventually, boom, gravity wins. It overcomes the material's strength and it pulls the whole thing into a sphere, which, by the way, is the most efficient shape in the universe.
So that leads to a pretty obvious question, right? What's the tipping point? How big does a moon made of ice or rock have to get before it goes from being a lumpy potato to a perfect marble in the sky?
And you know what? There is. The magic number is roughly a 300-kilometer radius. Doesn't matter if the moon is made of ice or rock or iron. Once it gets to about that size, its own gravity is powerful enough to squeeze it into a sphere. That is basically the entry ticket to the giant moon club.
And you know, the stuff a moon is made of really matters. I mean, check this out. A hypothetical moon made entirely of diamond, with its unbelievable strength, could actually stay lumpy until it was a whopping 2,400 kilometers in radius. It's just a fantastic way to picture the cosmic forces we're talking about.
Okay, so now that we know what makes a giant moon, let's actually go visit the most famous family of them all, Jupiter's Galilean moons. Galileo discovered these four, and they're so diverse, they're basically a miniature solar system all on their own.
So in order of how far they are from Jupiter, we've got Io, Europa, Ganymede, and Callisto. And let me tell you, each one is a completely unique world, shaped by just how close it is to that massive gas giant.
And this is where that mini solar system idea really clicks. Think about it. When these moons were forming, it was way hotter closer to Jupiter. This meant that only really dense stuff like rock and metal could condense down to form that innermost moon, Io. But farther out, where it was cooler, lighter stuff like ice could form too. And that's exactly why the outer moons, Ganymede and Callisto, are so much less dense. It's a perfect mirror of how our own solar system is laid out.
Okay, now let's zoom in on the two innermost Galilean moons, because this is where Jupiter's influence creates some of the most extreme environments you can possibly imagine.
First up, we have Io. And forget what you think you know about volcanoes. This place is, hands down, the most volcanically active body in the entire solar system. Its surface is constantly being repaved by sulfurous lava, burying any impact craters under like 100 meters of new material every million years. It's a world in constant violent geological turmoil.
So what's going on here? Why is it so ridiculously active? It's all about tides. Io is so close to Jupiter that the planet's immense gravity is constantly stretching and squeezing it. And to make things even crazier, it's also in a gravitational tug-of-war with the next moon out, Europa. This constant flexing, this push and pull, generates an incredible amount of heat inside Io's core, and that is what fuels hundreds of active volcanoes.
And then right next door to this volcanic hellscape, you have something completely different, Europa. Its surface is this smooth, bright shell of water ice. But the really exciting part? Beneath that shell, scientists are pretty sure there's a global ocean of liquid water, an ocean that might hold more water than all of Earth's oceans combined. Just let that sink in.
And we have some really good clues for this. High-res pictures show that Europa's icy crust is fractured into these huge plates, these massive ice rafts and flows. And they look almost exactly like the ice rafts you'd see in Earth's Arctic Ocean. This is a huge hint that the ice is floating on liquid water down below, water that sometimes erupts to the surface, keeping it all looking young and smooth.
All right, from the chaos of Jupiter, our tour is going to make one final stop, over at Saturn. We're going to visit a moon that might be the most familiar yet profoundly alien place in the entire solar system, the smog-shrouded giant, Titan.
Just look at this comparison. It is absolutely uncanny. Titan has a thick atmosphere, thicker than Earth's actually, and just like ours, it's mostly nitrogen. It has weather. It has clouds, rain, rivers, and lakes. But here's the twist. On Titan, it is way, way too cold for liquid water. So instead, the entire weather cycle is based on methane. It literally rains liquid methane from the sky, which carves out rivers in the landscape and pools into these vast lakes of methane and ethane. It's like this eerie mirror of Earth, but with a completely different chemistry.
And that leaves us with a really profound final question, doesn't it? We know Europa might have the ingredients for life as we know it, liquid water. But what about a place like Titan? With its thick atmosphere, its complex organic chemistry, and all that liquid on its surface, could it possibly host a form of life that's completely different from ours, one that's based not on water, but on methane? These giant moons, they aren't just worlds beside our own. They're worlds of endless, fascinating questions.